Welcome to Linear Algebra. Today we will learn the Gaussian elimination algorithm for solving a system of linear equations. So let's begin by making clear what we mean by a system of linear equations. A system of m equations in n variables is written as a11x1 plus a12x2 plus a1nxn, n variables, is equal to b1. Second row, a21x1 plus a22x2 plus a2nxn equals b2. All the way down to the mth equation, am1x1 plus am2x2 plus amnxn equals bm. It is customary to put some kind of brackets around it, either a large set of brace brackets or maybe two round brackets. And the goal is to solve these equations simultaneously. And by that we mean find values of the variables x1 to xn in this case, that satisfy all the equations at the same time. So let's begin with a simple example. And our exercise is solve simultaneously. And the first one is this system. 2x1 plus x2 plus 3x3 equals 1. 5x2 plus 5x3 equals 2. And x3 equals 0. Let's put our brackets around it, brace all round. And for convenience, let's call this equation 1, equation 2, and equation 3. So what are we really doing here? What are we looking at? The first equation is a plane in R3. R3 is our three-dimension space that we live in. Think of this as the corner of the room. And this is your x, y, and z axis. Or you could say x1, x2, x3 axis in keeping with our notation here. And the first equation, 2x1 plus x2 plus 3x3 equals 1, is a plane in R cube. That's how it's said, R3, R cube. That's referenced to three-dimension space. And it's written in the stylized R. In a textbook, it would be bold R, but it's hard to show bold when writing. All right, so the first one is a plane. The second equation, 5x2 plus 5x3 equals 2, is a straight line, and so is the third. So keep that geometric intuition very clearly in your head. The way we'll solve this is almost natural. The method is called back substitution. And that's a great name. But it's a very natural way of solving the system. You have x3 equals 0, right? 3 gives us x3 equals 0. Plug into 2. So you get 5x2 plus 5 times 0 equals 2. So you get 5x2 equals 2. or x2 equals 2 over 5. So I want this to fit on a page, so I'm just going to shrink that down a bit. There we go. Hope you caught up with me now. So what do you think the next thing will be? Well, we'll put x3 equals 0 and x2 equals 2 over 5 into 1. And we get 2x1 plus 2 over 5 plus 3 times 0 equals 1. So that simplified gives us 2x1 equals 1 minus 2 over 5. That's 3 over 5. And x1 is 3 over 10. That's it. So the answer is x1 equals 3 over 10, x2 equals 2 over 5, and x3 equals 0. Now keep that geometric intuition in mind. This is a point on the plane. These three equations intersect in a point, and that point, you can write it as we just did, or you can just write it as point XYZ format. So the plane and the two lines intersect in a point. And the point is 3 over 10, 2 over 5, and 0. Now a second exercise is what illustrates the Gaussian elimination algorithm. We'll prove it later. Today we just want to get the mechanics down. So this one is not so easy as the previous one. 2x1 plus 6x2 plus 8x3 equals 3, and 6x1 plus 8x2 plus 18x3 equals 5. Again, we'll call it equation 1, 2, and 3, but this time just allow me to call it equation 1, equation 2, and equation 3. You'll see why in a moment. And now we're going to do the Gaussian elimination. So another great word, as back substitution really conveys very nicely in one phrase what we did in example 1. Gaussian elimination, the word elimination also very nicely conveys what we're about to do. So what we'll do is we will make this look like the previous one. The previous one had no term there, and there. And that made it easy. That's why we could finish it off with back substitution. And we'll do the same thing here. We're going to get rid of this, this, and this. And we're going to get rid of it in a way that maintains the equivalence of the system. To understand that requires additional information that is not in today's segment. Today we just want to get the mechanics down. We're going to get rid of the 2x1 in the second equation. And to do that, we will do equation 2 minus equation 1. Now you see why I wrote it out as equation, just to make very clear what it is we're doing there. So we get 2x1 plus x2 plus 3x3 equals 1. And since it's the first time, right, it helps to write separately the subtraction process. 2x1 minus 2x1, and you get 0. That's the whole point. 6x2 minus x2 gives you 5x2. Eight x3 minus 3x3 gives you 5x3. And then we can do 3 minus 1 in our heads. So 3 minus 1 is equal to 2. Next, we will do equation 3 minus something times equation 1 with a view to making the 6x1 0. What will it be? 6x1 minus coefficient times 2x1 giving 0. That's going to be 3. 3 equation 1. And once again, I will work it out separately here. 6x1 minus 3 times 2x1 is 0, as we wanted, right? We're trying to make it look like the previous one, because then we can finish it off with back substitution. 8x2 minus 6x2, 8x2 minus 3 times x2 is 5x2, and 18x2 minus 3 times 3x2 is 18 minus 9 is 9x2. So I get 5x2 plus 9x2, and then 5 minus 3 is just 2. Now, this system is equivalent to the original system here. Now, that's a bold statement that needs explanation, and the explanation will come later. Now, just make sure you know the dynamics of the Gaussian elimination algorithm. All right. Now we want to make the 5x2 in this part here 0. And we'll do that by doing equation 3 minus equation 2. We don't want to touch equation 1, because then we'll get something back down here and go around in circles. So this is 2x1 as is, plus x2 plus 3x3 equals 1. 5x2 plus 5x3 equals 2. And once again, let me just pull it out here. So 5x2 minus 5x2 equals 0. That was the whole point. 9x2 minus 5x2 is 4x2, and 2 minus 2 is 0. Now look at this system. We have it in that nice format, don't we? The format where we can do back substitution and finish it off like the previous one. And in fact, let me grab the previous one and its solution. Well, start by doing this. Look at that. That's the same equation. Where you have 4x2 equals 0. I'm sorry, that's x3 over here, not x. This is 3. And it's 3 and 3 and 3. 4x3 equals 0. That's just x3 equals 0. So it's the same system that we had before. And we will solve it the same way. So I'll just grab the solution from here. Bring it down here. And that's it. Where should I bring it? There we go. You can finish the problem by back substitution. So this is back substitution. What we did earlier is the Gaussian elimination. That's what you're learning in today's class. The back substitution is very elementary. All right, we're done with this problem, and we'll never write so much. We don't need the variables at all. We were just manipulating the numbers. So I'm going to write down in short what we did, and we'll never write so much again, equation 1, equation 2, no, none of that stuff. No need to write x1, x2 all the time like that. What we'll do is we'll write it in this format where we're just emphasizing the numbers that we are going to manipulate, and this is called augmented matrix. Now we haven't done matrices as yet, and don't think too deeply about this. This is just a way of writing it so that we don't have so many variables. This line here just indicates that, the numbers on the right of it are on the other side of the equation. And we can refer to it as R1, row 1, or R1, or my preferred way is sort of R subscript, and then this is R2 and R3. And then the operations are very simply written too. So the first manipulation is this R2 minus R1, R3 minus 3R1, and we get 2, 1, 3, 1. I'm just copying down from here. 0, 5, 5, 2. You see where I'm copying down from, right? I'm just looking up here. And the last one is 0, 5, 9, 2. So no need to say equation 3 minus 3 equation 1. It's just a little bit simpler. And then you have R3 minus R2. And you have 2, 1, 3, 1, 0, 5. And I'm copying down from here. 5, 2. You see the variables are completely unnecessary. Okay. And then you finish it off by back substitution. In back substitution, you write as much as you want to solve linear equations, which you know how to do. So that was the one and only time that we will write so much. No need for the x1, x2, x3. This is all that's needed. All right. And that's it. That's the end of this segment. I'll see you in the next one. Bye.